Alright, let's get after this. 11.4 video notes, arc length and sector area. Before we jump into it, I want to just review two things here real quick. So make sure you guys know the difference between area and circumference, you know, formula wise, because they're kind of similar but they're kind of different. So for either of these, what do you need to know about the circle? Like, what's the one thing that you have to have? The radius. Alright, if they give me the diameter, I can use that and cut it in half, but I really need this radius here. So for either circle. Now area is referring to how much space is inside of here. If I wanted to, you know, like pour cement or sod or something like that. But so what's my formula for area? Don't all yell at once. This is your shot to be on the big screen. Pi r what? Pi r squared. First block there, a little sleepy, so bear with us. And then circumference wants to know the distance. It's a length. It's how far it is all the way around the circle. You know, another word for circumference that's kind of the same is perimeter. It wants to know the length if you walked all the way around. And the formula for that is very similar to this one. You just take the 2 and you put it in front. So 2 pi r, or some people prefer pi d. So we need those two today, because what we're doing today is we're not finding the entire area, but we're finding part of the area. And we're not finding the entire circumference, we're finding a piece of the circumference. So that's going to set us up for our notes. So let's jump into this, go back full screen. So the sector of a circle is it is the area in a circle contained by two radii, or radiuses. So if you create two radius and then you shade that in a little inside area, that's what's referred to as a sector. So it's that little piece right here. So how do you think I could do that? How can I find the area of just this piece of pizza, but not the whole circle? Like, what am I going to need to do? Like, I think if, you know, if the circle was like this, and I needed like exactly half of it, you know, if I needed just half of it, I'd be like, oh, you know, that's just 1/2 of pi r squared. It's half of the whole circle. But this one's not half. It's like a weird amount. So who's got an idea? Chrysler? Exactly. So for all of these, the circle's 360. And what you're going to do is you're basically going to put in whatever degrees they give you out of 360, and you're going to multiply that by the entire circle. So it's basically a fraction of the whole circle. All right? So on this one, it would be 50 out of 360 times pi, and then we need the radius. This changes for each problem. So for this one, the radius is 6. Now, sometimes they put these in decimals, sometimes they leave them with pi in there. It kind of all depends. If you're going to use your calculator, I would just put this, either use the fraction key, or you could just put this in as like that, and then just times pi times. That would be a way to enter it into the calculator. I'm going to show you how to do it old school, just so that if you run across one on a standardized test that they leave pi in there, we can do that as well. So I'll do it over here. So 50 out of 360 times, well, 6 squared, that's 36 pi. All right. And then I just kind of treat that as over 1, because whenever you multiply it by a fraction or a whole number, you can just put it over 1. And then now we can do some old school tricks, or, you know, like when you multiply fractions, you just pretty much just go straight across. Just multiply straight across. But I'm going to get some big old numbers. So I'm allowed with fractions, whenever I'm multiplying two fractions, I'm allowed to cancel up and down, and I'm also allowed to cancel on diagonals. So you say it's like a bow tie. I can cancel on a bow tie whenever I multiply fractions. So first thing I'm going to do is I'm going to cancel up and down. I'm going to divide by 10 and divide by 10. That significantly lowers my numbers. Now if I cancel on the corners, this 36 cancels with that 36. And basically all that's left is I have 5 pi over 1, which is just 5 pi. Now I bet if you punch all this into the calculator over here, you should get the same answer as if you got 5 pi. But on a lot of standardized tests, this is the kind of the way that they like to go. So I'll give you a little mix of all of them when we're doing homework and we're doing tests. So I guess worst case scenario, if all you can do, get the decimal. But if you're a stud and you want to see what you can do, try to do it in pi as well. All right, let's move forward. So that was finding the area of a sector. So we got a couple of examples. I'm going to stop the video, give you a shot to try both of these. Maybe. Back in action. All right, example 1. Let's go ahead and put it up here and see what we got. So we're finding the area of a sector, which is a part of a circle. So everyone's going to start off something out of 360 times pi something squared. That's the template. Every problem starts off that way. The two ingredients I need to know how many degrees, which they hooked me up with right there, and I need to know the radius, which is right there. Now, some of you might be sharp enough, instead of doing this big old fraction, 45 out of 360, you might be like, well, wait a minute, 45 is exactly 1/8 of a circle. So you may have kind of had the foresight to just say, that's 1/8 of a circle. But maybe not. I'm just going to go through like we didn't. Alright, so let's get after this. You could use your calculator right now, or I'm going to kind of do it a little different way. 45 out of 360 times, that's 256 pi over 1. And I'm going to attempt to do some canceling. I can kind of go any direction I want. I see that 5 goes into this number, and 5 goes into this number. That'd be 72. And then 9 goes into both of those, so that's my 1/8. And then I believe 8 goes into 256. 3 would be 24. Yeah, 32. 8 goes into there 32 times. So I'm thinking this is going to shake out to be 32 pi. And put that in the old calculator. 32 pi. 100.53. Sweet. Now what about my units? Feet squared or feet cubed? Feet squared. Area is always squared. Good deal. Alright, let's move on to number 2. So I'll go a little quicker on this one. So 285 out of 360 times pi r squared. Might as well just put over 1. I'm going to have to do that eventually. So that's 285 over 360 times 64 pi over 1. This one might be a little mess here. 5 goes into both of these. Well, I don't know, a couple different ways I could go. 5 goes into both these numbers. I'll see that first. So that goes in there 57. And 5 goes into here 72. And then I know 3 actually goes into both those numbers. The trick for 3 is if you add up the 2 digits and 3 can go into that number, then I know 3 can go into 57. And 3 goes into both of these. So 3 goes into 57 19 times. 3 goes into here 24 times. I think I've done all I can going top to bottom. But now I could go kitty corner. 8 goes into here 3. 8 goes into here 8. And that might be as good as I can get. I don't see any other things. So that's 80 times 7, 80 plus 72, 152 pi over 3. And I know 3 doesn't go in there because that only adds up to 8. Now, I'm going to try to punch that in and tell me if that's the decimal you guys got. So 152 pi divided by 3. Did you guys get 159.17? Beautiful. 159.17. And again, it will be inches squared. Oh man, we gotta hurry up. Time's running out. Alright, next. Same exact idea for arc length. Arc length is just, and I'll probably just use the calculator on these next ones. Arc length is just a fraction of the circumference. It's just a portion. So, like on this problem, the arc length that we're referring to, it's this little piece right here. I just want to know how long that little piece is. So it's the exact same setup. It is a fraction of the circumference. So it's going to be something out of 360 times 2 pi r. And that's kind of the general template. So I'll bust this one out real quick. So we have 50 out of 360 times 2 pi 6. I like to just put that over 1 if I'm doing it by hand. And we'll crank this out, cancel those dudes. 5 over 36 times 12 pi over 1. I see 6 or 12 goes into both those numbers, so this one's going to be nice. 12 goes into itself once, goes into here 3 times. So now I can multiply across the top. 5 times pi, 3 times 1. There would be a good old SAT, ACT answer. 5 pi over 3. Now if I want to clean it up and do some decimals, 5 pi divided by 3. Looks like 5.2-ish. So about 5.2. My units here are just feet. Sorry about that. Whew. Blew your ears out. 5.2 feet. Yeah, next year they're going to have to deal with that. Alright, we got a couple examples maybe. You know, I'm not going to do number 3 because number 3 is exactly like we just did. I'll leave that, you know, to you. Maybe I'll pause it and do it after class. But number 3 says find the minor arc GH. So that means find this piece. But then you got to be careful. This one says find the major arc. So this one I need to find this length, which is almost the whole circumference. So the only thing you got to kind of watch on something like that is your setup. You know, so over here, the red problem, it would be 120 out of 360 times 2 pi r. You can jam that in your calculator and get an answer. The blue one, you may have to use subtraction because when you do out of 360, the blue represents, you know, 360 minus the 80 up above. So this is actually 280 degrees. They don't give you that, but you actually have to find that little piece. So this will be 280 out of 360 times 2 pi 3. So we can bust these out. We got knock off a couple zeros. 12 goes into there once. 12 goes into there 3 times. 3 can't do nothing with 2 and 11. So I'm just going to go straight across now. 2 times 11 times pi is 22 pi. 3 times 1 is 3. We are reduced. I'll let you guys turn that into a decimal. Probably know how to do that by now. Over here, I'm going to knock off some zeros, dividing by 10. 2 goes into both of these numbers. I can get something bigger. 4 goes in there. 4 goes in there 7. 4 goes in there 9. So I have 7 over 9 times 6 pi over 1. And then 3 and 9, or 3 can go into both of these dudes. 3 goes in there twice. 3 goes in there 3 times. So we're looking like we got 14 pi over 3. You know you're done when these two numbers you can't reduce that. Like I say, most of the time I'm going to put decimals in there, but occasionally I might leave the answers with pi in there. Alright, the practice is on the rest of the sheet. See you.